Hello, welcome to SAT/ACT radical equations lesson. During this lesson we will study two methods of solving radical equations. Example: solve for x. Square root of x minus 1 equals x minus 7. This is an example of a radical equation because in the left side we have a binomial x minus 1 under the radical sign. Graphical solution. Let us draw the graphs of the left and right sides and find the point of intersection. The graph of the left side is the graph of a radical function y equals square root of x minus 1. The parent function is y equals square root of x, and it is shifted 1 unit to the right. The vertex of the graph is at the point 1, 0. The other function, y equals x minus 7, is a linear function. It has slope, coefficient of x is 1, and y-intercept is negative 7. But we cannot see y-intercept on the diagram because we have to extend the line and y-axis. But you can see x-intercept. X-intercept equals 7. If x equals 7, 7 minus 7 would be 0. Y would be 0. Therefore, we can draw this line using x-intercept and slope. You can see the line on the diagram. The two lines intersect at a point with coordinates 10 and 3. X is 10, y is 3. Therefore, the two functions would be equal when x equals 10. The point of intersection is 10, 3, and x is 10. Therefore, 10 is the solution of the given radical equation. I prefer to solve this equation algebraically. In order to solve this equation algebraically, we must square both sides to get rid of the radical sign. But squaring is very dangerous because when we square both sides of the equation, we can get so-called extraneous or fake roots. Let us see how it works in this case. We squared both sides. Then in the left side we get radicand x minus 1 because square root and square cancel out. And in the right side we apply the formula square of difference. Square of difference of x and 7 is square of the first term, x squared, minus twice product of the terms, minus 14x. Terms are x and 7. Product of the terms is 7x and twice product is 14x. Plus the square of the second term, 49. Then we move left side to the right side and we change the signs. X into minus x and minus 1 into plus 1. And on the right side we combine like terms. X squared we copied, minus 14x and minus x is minus 15x, 49 plus 1 is 50. Then we switched the sides. Left side is now right side, and right side is left side. Quadratic trinomial x squared minus 15x plus 50 is factorable. We can represent it as the product of two factors x minus 5 and x minus 10, because the product of minus 5 and minus 10 is constant term 50, and the sum minus 5 and minus 10 is negative 15, is second coefficient. The product of two factors equals 0 when either first factor equals 0 or second factor equals 0. x minus 5 equals 0 gives x equals 5, and x minus 10 equals 0 gives x equals 10. But x equals 5 is not the root of the original equation. It is so-called extraneous or fake root. In order to find out whether the root is real or extraneous, we must substitute this root into the equation. Let us substitute x equals 5 into the original equation. We get in the left side square root of 5 minus 1, and in the right side 5 minus 7. 5 minus 1 is 4, 5 minus 7 is negative 2, square root of 4 is 2, but 2 doesn't equal to negative 2. It's wrong. Therefore, x equals 5 is not the root of the given equation. It's a fake or extraneous root. Let us check the other root, x equals 10. Substitute into the equation. Square root of 10 minus 1 equals 10 minus 7. Square root of 9 equals 7. 3 equals 3, true. Therefore, x equals 10 is the only root of the given equation. So, conclusion. Do not forget, when you square both sides of the equation, you can acquire so-called extraneous or fake roots. One of the easiest way to recognize the extraneous root is to make a check. So, this solution which we got here, it requires check. Check is mandatory for this solution. If you do not perform the check, then you can get fake roots, extraneous roots. This is the end of this lesson. Thank you very much for participation. This was Vladimir Luzgin. Goodbye.